this recording, we are going to look at logarithmic functions and their graphs. Okay. So there's a few things that we have to know or pay attention to when we're dealing with logs, and those are the different rules that we have set in place for using our logs. Now, a lot of these rules and properties are set so that you can evaluate logs and work with logs without necessarily needing to have a calculator. For example, if we start with the fact that we have an equation where y equals log base a of x, then we can essentially rewrite it such that we have the equation x equals a to the y. So what we're doing is we are essentially rearranging your equation so that we can put it in exponential form. So for example, whatever your log equation is set equal to, that is your exponent. The little tiny value off to the side would be your base. And then this value right here we would consider to be, say, the x. And so what we do with that is you would rewrite it. So see, we rearrange to where this becomes my base raised to the exponent equals x. Now in most cases, this form here we can solve without having to do calculators or too much math. Okay? So we're going to take a look at a couple examples doing just that. So here we have the log base 3 of 9. Okay, so here we want to evaluate, and it very clearly says do not use a calculator. So essentially what we're looking at is that this equation would be, say, set equal to x, so that we can rearrange it into its proper form. So here we've got this part right here would be your base, and then we have that this part right here would be your exponent. So we can rewrite our equation to say 3 to some value equals 9. Well, using exponents, we have a rule that says if your bases are the same, then your exponents are the same. So here we need to remember the rule that says if your a to the x has the same base, then x equals y. Then your exponents are the same. So what that means is, can I rewrite my 9 to give me a base of 3? Well, I can. So this becomes 3 to the x equals 3 squared. Since my bases are the same, it means my exponents are the same, so x is 2. And this would be the answer that we were looking for. And notice that none of that did we actually use a calculator. Now, the other equation that we have, notice here I have a fraction. So things are going to be rewritten slightly differently. Again, we can set this equal to x so that we can rewrite our equation. So we have 2 to the x is equal to 1/4. Well, what we have to remember here is that this would be the same as saying that 2 to the x is equal to 4 to the negative first power. Okay, so remember, my power here is positive. In order to make it negative, we have to flip it back up to the top. So now we have to look at, can I change my 4 into a base of 2? Well, in this case I can. So this becomes 2 to the x is equal to 2, and then this would become a negative 2, because 2 squared is 4 times my negative 1. Now my bases are the same, therefore x equals -2. And this, again, was what we were looking for. Now the last one we have is this bottom one, and again we can set it equal to x. So here we can set this equal to x. So we're going to have 8 to the x equals 2. Remember, this is 2 to the first power. So now I have to look at, can I change my 8 into a base of 2? Well, this can become 2 to the third is still raised to the x equals 2 to the first power. So I have here that 2 to the 3x equals 2 to the first power. Since my bases are the same, I can set my exponents equal. So I have that 3x is equal to 1, so x equals 1/3. And again, that's what I'm looking for. So in a nutshell, that is how you could evaluate your logs without using a calculator, applying your exponential rules. Now, another thing that we can do with logs is we can get specifically into just simply converting back and forth between exponential and logarithmic forms. And this is going to deal with what we were just doing in the previous examples. Only here, we're not asking you to solve. We are purely asking you to flip back and forth between the two forms. So here I have 5 to the -3 is equal to 1 over 125. So what I have to remember here is I have to remember my 5 is your base. Okay. This exponent here is what you are going to equal. And so we need to rewrite it. So this becomes the log of your base 5 of your stuff 1 over 125 is equal to your exponent -3. Okay. So again, we can do it again. E is going to be your base. So this is going to be your log base E. This 4,000 is what we're taking the log of. So of my 4,000 is equal to my exponent, -t. And since all we want to do is convert, that's all you would do. You would simply leave it at that. Okay. Now we can go backwards. So again, remember that this is going to be your base. This one right here is going to be your exponent. And this one right here is what you're going to be equal to. So we can set it up. So we're going to go base to the exponent is equal to our number. So my base is 4 to the exponent, which is t, is equal to my 7. And that is how you would convert going the other direction. Okay. Now, there's a couple rules that you just need to simply know, which is going to be the following. Log base anything of 1 will always give you a 0. Okay, this is going to come from the idea that a to the 0 equals 1. Okay, so this part right here is what we are referencing, and so this is just a fact you need to remember. Now the other thing we need to remember is that if the base and what you're taking the log of are the same, then the result is 1. Again, it comes from the idea that a to the first power is going to spit itself out as an example. Okay? And so you have to use that idea depending on the problems that you are solving. Now, another idea that we have has to do with evaluating using the calculator. And to do that, we have to keep a couple things in mind. First of all, we have what's called a common log. Common logs are essentially where we have a base of 10. So here, we're looking at the rule log base 10 of 1 equals 0. So here, that means my a value was 10. And again, log base 10 of 10 equals 1. These are for what's called the common log, or the base 10 log. Now these other properties that we have right down here are properties to keep in mind for when you are solving, and they say that the log where the base of your log and the base of your exponent are the same, then the result is whatever that exponent was. Here, if I take my base of an exponential function and the base of my log are the same, then whatever I'm taking the log of is my answer. Okay? Natural log, or the ln button that we have, is essentially log base e. Again, the natural log of 1 will give you 0, and the natural log of e will give you 1. Those are those same two properties that we've talked about before. The biggest thing that we have to keep in mind is this property downstairs, or down here, that says you cannot evaluate a log or a natural log of negatives or of 0 since they do not fall within your domain. So the biggest thing that you have to keep in mind is that if you have the log of, say, negative b, this does not exist because the negative does not fall within our acceptable domain that we have. Same thing if I'm trying to take the natural log of, say, negative b, we have that this does not exist. Okay, we cannot do it because it falls outside the scope of what we are looking at. Okay. Alright, so the big one that we need to look at is we need to look at graphing. So graphing logs, the first thing you want to do is you always want to rewrite your log function into an exponential. So here I have y equals the log base 2 of x. So I need to rewrite that into its exponential. So remember, 2 is my base, okay? Y is my exponent, x is what it equals. So I have x equals 2 to the y. And then we're going to make a xy table, but it's going to look slightly different than the ones you've used before. So we have x, so in other words, x equals 2 to the y, and then we have our y. So my table here is going to have my 3 columns just to help me keep things straight, because in this instance we are doing something unfamiliar. We are choosing values for the y. And in choosing values for the y means that we are solving for the x. which is different. Normally, we would be choosing values for the x and we would be solving and dictating the y value. But here, we're flipping things around. So we have to choose my values of y in order to solve for my values of x. So I would make life easy. I might work with -2, -1, 0, 1, and 2. And in doing so, I have this equation I have to solve for. So this is going to be 2, and I have to input my power. Well, here, my power is a -2. So if you remember the rules, a negative we don't like, so this is going to be the same as 1 over 2 squared, which is 1 over 4. So my x value is 1/4. Now I have 2 raised to some power, and in this case my power is a -1. So I have 1 over 2 to the first, which is 1/2. So this is going to be 1/2. Next I have 2 to some power, where that power here is 0. And we know our rule, anything raised to the 0 gives you 1 as a result. So this is a 1. So what you should notice is that we are filling in my x table. However, my coordinate point is still going to go x comma y. Okay. So here, my last two, I have 2 to something. This is to the first. 2 to the first is going to give you 2 as a result. And then I have 2, again raised to the something. That something is a 2. 2 squared gives you 4. So my coordinate points are still going to go x comma y. And I still have my graph, which is x is my horizontal, y is my vertical. So the first thing I would do is I would start down here with my whole numbers. So I would start here with my graphing. So the first thing I have is the point 1, 0. So notice, this is, we're going to go over 1 and we're not going to move. So 1, 0 is going to cross my x-axis. The next thing I have is I have over 2 and then up 2. So 1, 2, 1, 2 is right here. And then I have over 4. Or sorry, over 2 up 1. So not this point, it's right here. And then I have over 4 up 2. So over 4, 1, 2. So see how easy it is to kind of get yourself a little screwed up, which is fine. Some things that might help is if you actually write your coordinate point off to the side. This is the point 4, 2. This was the point 2, 1. This was the point 1, 0. This is the point 1/2, -1. This is the point 1/4, -2. Whatever it is you need in order to help certainly would work. And so now we have the fraction points. So I have the point 1/2 and then down at -1. So I'm down at -1 and I'm over kind of about a half. And then I have the point 1/4, -2, so even closer to my y-axis. And what you should notice here is that this value is kind of going up in that direction. And then here we are slowly coming down and we are going to hug that y-axis line. Okay. Now, a few things that we needed to remember is that when we graph logs, first you should cross the x-axis, okay, which is what we And so that is really the most important thing that we're kind of looking at, is that you need to make sure that this was originally a log function, which means we needed to have crossed that x-axis. Remember, exponential functions, if that's how you started, would cross the y-axis. So here we're going to cross the x-axis. We're going to get infinitely close to the y-axis. Okay, those are the two things that we kind of have to remember. Alright, so let's look at another one. Okay. So we have my function equals the log of the base 1/3 to the 5 minus x. So again, you want to start by rewriting this into its exponential form. So remember, this is going to go base over to my exponent equals my stuff. So this is going to be 1/3 to my y is equal to 5 minus x. But then we need to be able to solve for x, so I need to subtract 5 from both sides. So I have a negative 5 plus my 1/3 to the y is equal to a negative x, and you'll see why I wrote it this way in a second. And so now I need to divide everything by -1, so this becomes 5 minus my 1/3 to the y equals x. And so here, this is the equation that I have to work with. And so again, you can set up your tables. So we have my x, we've got our equation that x is 5 minus that 1/3 to the y, and then we have our y values. Okay. Again, remember my y value here, we are choosing the values so that with my x we can solve for these values. And so here I again would choose the same values, where I have -2, -1, 0, 1, and 2. And so again, I would plug them in. And so in this case, I'm going to have 5 minus, and I have 1/3 raised to the something. Well, this something is a -2. And so here, this is going to be the same as 5 minus. -2 says this becomes 1 over 1/3 squared. So this is 1 over my 1/3 squared. And at this point, if you wanted to use your calculator, you could. The other thing that you could recognize is that this is going to be the same as 1 over 1/9. So here we're going to have 5 minus 1 over my 1/9. Fraction rules say keep the top, multiply by the reciprocal of the bottom. Makes this the same as 5 minus 9, which is a -4. So we get a -4 as this result. Again, if it helps you keep things a little bit clearer, you can write the coordinate point next to it. So this is the point -4, -2. And now we have to do it again with my -1. So here, this becomes 5 minus my 1/3 raised to the value. This value is a -1. So this is going to be the same as 5 minus 1 over 1/3, which is going to be the same as 5 minus 3, which gives me 2. So here I'm going to have the coordinate point 2, negative 1. Now I have 5 minus my 1/3 raised to the 0. So this is going to give me 5 minus 1, which equals 4. So I have the point 4, 0. This is now 5 minus that same 1/3 raised to its power, and it's going to be the power of 1. So this is 5 minus 1/3, which in this case you could go ahead and use the decimal because we're kind of looking at how close we are. So this would give me the decimal 4.67 repeating. So here I'm looking at the coordinate point 4.671, and then I have 5 minus 1/3 squared. Again, I could plug that in my calculator and you're going to get roughly 4.8. So this is the point 4.82. Okay. So we need to go ahead and graph these points. So here my first point that I have is the point -4, -2. So I'm going to come over to -4 and I need to go down to -2, so that point is right here. Then I have the point 2, -1. So I am 1, 2 down at -1. I have the point 4, 0. So 4, 0 crosses right here. I then have the point a little over 4.5, so a little over 4.5 and up at 1. And then I'm really, really close to 5, and I'm up at 2. So what you should be seeing here is that my graph is kind of coming in like this. It's going to cross my points here, and then it's going to shoot up, but it's actually going to hug near where I have that x equals 5, and that purely has to do with this 5 right here. Okay, so instead of hugging the axis, which is what would have happened if we didn't have this 5, we've shifted our graph over, and so we're going to hug very close to that point there. Okay. Now, another thing that we can look at is we can look at solving your logarithmic equations. So these equations are going to contain either logs or natural logs, usually not both together. But what we have to remember is that rule that we have that says if you have log base A of x equals y, then you can rewrite it into x equals a to the y. So you need to remember that rule when you're solving, because at some times or some points you need to be able to interchange back and forth, and that's kind of the method you use, which is that you want to try and interchange into that exponential form, because that is the easiest form to be able to work with, especially if you're solving without a calculator. So here I have log base 16 of x equals 3/4. So I'm going to rewrite this into 16 raised to the 3/4 equals my x. Now with this, I have to remember that when we're talking about the top here, we are talking about a power. However, when we're talking about your denominator here, so my 4, this is going to be your root. So I need to rewrite this equation here to be your root. And because this has numbers, we can go ahead and rewrite it so that we are dealing with 16. We are taking the fourth root of it, and then we are raising it to the third power. And this whole thing is going to equal my x. Okay? So here the fourth root of 16 is going to give me a 2 raised to the third power equals my x. And then 2 cubed is 8. So 8 is my answer. Now let's look at this other one. Here I have a base of 3, and I'm looking at 9 to the 2x. So I'm going to rewrite this again, and it's going to become 3 to the negative 2 is equal to 9 raised to the 2x. So here I want to apply the rule. So I want to apply the rule that says if a to the x gives you a to the y, then x equals y. So if your bases are the same, then your exponents are the same. So can I change a 9 into a 3? Well, the answer is yes. So this becomes 3 to the negative 2 is equal to 3 squared raised to the 2x. Here my power rule says multiply. So this becomes 3 to the negative 2 is equal to 3 to the 4x. Because of that, now we are able to solve that negative 2 is equal to 4x. Divide everything by 4, and we have that negative 2 over 4 equals x, and you need to reduce. So negative 1/2 equals x, and this is my answer. Okay. Alright, this one is a little different because we are using the natural log. So one thing that you need to remember is that my natural log is the same thing as log base e. So in some instances, what we can actually do is we can rewrite this equation to say log base e of the x plus 1 equals 3. And now we can interchange or rewrite the equation using the rule. So this becomes e to the 3 is equal to x plus 1. All we have to do in this case is we just simply have to subtract 1 from both sides. So we have e to the 3 minus 1 equals x. And this is called an exact answer. Okay, so this right here, what we're looking at is that this is an exact answer. There's no decimals. And so we could leave it in this form, or you could pull out your calculator and you could actually do that math, and it's just going to depend on what it is you're looking for. So if you wanted to actually know what this decimal is, you would hit your E button. So mine is right here. It says E to the box. So I would hit that. I'm taking E to the 3, and then I'm subtracting 1, and hit enter. And I get the decimal 19.085, blah, blah, blah. And so you would round to whatever decimals that you were asked to round it. Here, we wanted the exact answers, so you would leave it in this form. Okay. Now, this is just one way to do it. The other way to do it would have been to raise to the power of e. Okay? So, if you don't remember that the natural log is the same as log base e, what you need to remember is that the natural log and e to the x are inverses. of each other. Okay, so this means they undo each other. Okay, so simply put, they undo each other. So I have the natural log of x plus 1 equals 3. So what I could actually do is I could raise the whole thing to my power of e. So to do that, I could raise this entire equation with e. And what that's going to do is that's going to change this into e to the natural log of x plus 1 equals e to the 3. Well, we just said natural logs and e's undo each other, so e to the natural log goes away, leaves me with x plus 1 equals e to the 3, which is what we just had up here. So then we end up getting that x is equal to e to the 3 minus 1. Same exact result, just a different way to approach it. Okay. Now the last example I wanted to work through is this one, where you can see I'm taking the natural log of the natural log. So that means the first thing I have to do is I actually have to apply that idea of raising my equation to the power of e. So here I'm going to raise my equation to the power of e. So my equation here was the natural log of x squared equals 0. And what that's going to do is it's going to rewrite it. So I'm going to have e to the natural log of my natural log of x squared equals e to the 0. And so here we can only look at the first pairing, so this group right here. And so my e to the natural log in this point right here is going to cancel, and it's going to leave the parenthesis behind. So I'm going to have now the natural log of x squared, and here e to the 0 when we evaluate gives you 1. Now again, I have to simply redo what I just did. So I am going to raise my equation back up to the e. So this is going to give me e to the natural log of x squared equals e to the first. Again, now we can look again at my e and natural log. They are going to undo each other. This is going to leave me with that x squared is equal to e to the first. I have to take the square root of both sides, so x is going to be plus or minus the square root of e. And again, if you wanted the exact answer, this is what it would be. And if you wanted the decimal, again in your calculator, you would have to hit your square root button, and then you would hit e, our power is to the first, and hit enter, and that would give you your answer. And so you would be looking at plus or minus 1.65. So depending on what you were asked or how you were supposed to round, that is what you would need to look at. Okay. So if you have any questions or concerns, please don't hesitate to let me know. Otherwise, thanks so much, and see you next time.